Okay. Just a minute. Okay. Nikhil is the new one. Okay. So, Nikhil, what you can do is you can go through the last class videos where we have discussed about the warm-up questions and the complexity part. Okay. So that will catch you up with the things. Hmm?
Okay, okay, Akshay.
Now, yeah, coming to the part. So while discussing the complexities, or in the last class, we have discussed about that there are two types of the data structures. One is the linear data structure and one is the non-linear data structure. Okay. So coming to the linear data structure, we have differentiate between the linear data structure and the non-linear data structure based on the how you access the element in there. Okay. So based on that part, the array is one of the linear data structure, which is really helpful in many conditions. So let's try to understand what are the situations where the array can be useful of, or what are the properties where what are the properties of the array which make it more useful in certain conditions. Okay. Before going there, what an array is? Okay. Before going to the array, let's discuss about what a variable is. Okay. So what happens is in our day-to-day life, we are using whatever the coding language you use, we always define something called variable. Variable is nothing but a name, but a pseudonym or alias or other name given to the memory address where you want to store some value. Okay. So with the variables, you always have a data type associated. Data type defines the characteristics of a variable. When we say characteristic of a variable means what could be the range of the value a variable can hold, what could be the size of the variable in the memory, like that. We have some primitive data type with us like int, float, double, character. Okay, these are the some primitive data type we have. Integer again divided into signed and unsigned. Okay. Now, this variable, just for example, hypothetically, if you want to visualize, this could be a part of a memory where you have the memory address hypothetically saying as ABC, but this whole will be represented by X. Okay, so this is a variable. Now, what happens is, suppose you are using or you are programming something and you need to use 10 variables of same type, let's say integer. What happens that is feasible to create 10 variables of integer. Then comes the requirement that you have to create 100 variables. Then comes the requirement that you have to create 1,000 variables. It becomes infeasible for us to declare 1,000 variables of the integer type. Okay, to resolve this problem, to rescue us from this problem, the array comes into picture. Array is nothing but a homogeneous collection of data. Is a homogeneous collection of data. When I say homogeneous means, it means that all the data belongs to the same data type. Okay. Homogeneous collection of data. Okay. The important, so how it look like is you can define a single array like this, a of 100. It means that int a of 100, it means that you have space or the memory for 100 elements of the integer type. Okay, you don't have to define the 100 variables to do that. Okay, the simple array of 100 is fine. Array is always take the contiguous memory location. Contiguous memory location. Contiguous memory location means, for example, it will be like something like this, one by one. Okay. This is the first memory address, this is the second, so I will writing the AD1, AD2, AD3 like that. Okay, so it always take the contiguous memory location in the memory address or the memory address space. Okay. This is it. Now, what happens with the contiguous memory location? You can make an analogy in the real life like the row of the house in a society. So, suppose you have the society, you have the row of the houses like this. Okay. The main advantage of taking the contiguous memory location is having the direct addressing. Direct addressing. And this is the most important property because of which we use the array in multiple situations. Most important property is direct addressing. What does the direct addressing means? Direct addressing means that if you have written a of 4, you can directly jump to any element within the array. Jump to any element in the array. Okay. So for example, if I want to access the fourth element, I will be just writing a of 4. So I will be directly accessing the fourth element within the array. And this is possible because of the base address or because of the base calculations. Okay. Whenever you define an array, it always hold the base address of the starting element. Base address of starting element, which is always a of 0. Then you will be doing some calculation, means you will be doing plus size of data type. Data type is the integer, so size of int into the element, whatever the element you want to access. So this will give you the exact address where you want to access the data. Okay. So this is direct addressing is very, very helpful. You don't have to go to the first element, second element, third element. You can directly go to the fourth element within the array. Okay. So this direct addressing is very, very useful property which makes the array very helpful in many scenarios. Another thing is it always say contiguous memory location, direct addressing. Another thing is this direct addressing or contiguous memory location makes troubles for the array as well. Okay. Why it makes the trouble for the array as well? Let's try to understand here. Suppose this chunk of memory, you already assigned something here. This much you have already assigned. Then you have this part. Then you have this part. This is also you have already assigned. This is also you have already assigned. This is free space. This is free space. Okay. Now you come to the you make a request to the memory to assign an array of 1,000 variables. What happens is this request can be satisfied by combining the free space F1 and F2. Okay. But even if there is enough space in the memory to satisfy this, we will not be able to or memory will not be allocated a array of size 1,000. Why? Because it is not contiguous. So contiguous memory location also have a drawback that even if the space in the memory is sufficient to satisfy the request of a array, then also it will not be able to do that. Okay. Why? Because they are not contiguous. Okay. This is one. So another thing is fixed size. Whenever you declare an array, you always need to give the size. Whenever you declare an array, or you declare an array, so suppose you are declaring an array like this, int a of 100. This size, this is you always need to provide. This you always, this is the size. This always you need to give, and it is always a fixed size. Okay, means in the declaration itself you have to give this. So what happens? Why this is a problem? Suppose in a program you never know that how much data you are going to deal with. So suppose you give an array of size, let's say a of 1,000, but among 1,000 you are using only 10 elements. Then what happens? It will be underutilized. This will be the case where the array is underutilized. Okay. Now another 990 space will be waste if suppose you have declared an array of 10, but sometimes you go for the requirement of 10,000 elements later in the program. Okay, what you have to do, you have to resize the array, so that will be overutilized. Both are the wrong. So this fixed size makes array difficult to scale. Scale means difficult to grow as the input size grows. Okay, so this is the issue with the array. Okay, so these are the array properties. One more thing is coming to the another point is indexing. In most of the languages, in almost all the languages, the indexing starts from zero. Indexing for the array always starts from zero. Okay, so suppose if you have defined an array, this is how we visualize an array, like this: a box with certain cells in it, like this. These are the cells. So if you have the elements, you can fill any element like 2, 1, 6, 4, 5, 3. Okay. So how the indexing work? 0, 1, 2, 3, 4, and 5. So what you do, you always suppose you have to access the fourth element. So fourth element is actually a of 3. Instead of saying a of 4, it is actually a of 3 because the indexing is started with 0. This is the fourth element in the array. Okay. So this is the fourth element within the array. This is how the indexing. Now, next important part is traversing. Traversing is an operation. Okay, always remember, traversing is an operation to access the data which is stored. I will write it here. This is an operation to access data stored in a data structure. Okay? Data structure. So traversing we are going to do for all the data structure which we are going to talk about. Okay. So how the traversing works for the array? What we will do, we will be using simple for loop. Int I equals to 0, I should be less than n, I plus plus. Okay. And you will be having printf or system.out.println anything, a of I. Okay. That's it. You will be looping, you will be processing. This is how you traverse. Then there comes types of array. Second comes types of array. So types of array based on the dimensions. Okay. Based on the dimension. So there could be 1D array, single dimension, like this. There can be 2D array, where you have rows and columns. And you have 3D array. Apart from the row and column, you have pages also, or frames. Okay. So how your 1D array look like? This is your 1D array. 2D array, this is 2D. You have different rows and columns. How your grid array look like? I will make it small, 3 by 3. This is. Then you have another one more frame here in the back of 3 by 3. And you have another frame in the back of 3 by 3. Like that, your array will look like. Okay. So there will be frame. So this is frame 1 of page 1, this is frame 2 of page 2, this is frame 3 of page 2. Okay. In the interview, this is the most important. Okay. Most of the problems are constructed in and around 1D array. Okay. So this is all about array. Okay. So guys, any doubt here?
Yeah, Nishan. As it's but we can use resizing of the array now. Means if
We can
we say that.
one more thing. It's a good point actually. Some of the differences told you about something called as dynamic array. Okay. There is nothing there is nothing like dynamic array. Some references told you that there is something called as dynamic array. Let me explain you that there is something called as dynamic array. So dynamic array, there is nothing as such. There is nothing we call as dynamic array. What happens is whenever your array is full. So generally, how the array is used. Let me tell you about. Array is used always with a size of one, starting with size of one, like a of one. Then what happens when this size is full? Then it always grow in the power of two. Then you will be assigning a new array of size 2 and copy all the elements from the old array to the new array. When this is full, then you will go by 2 by 2. So this is like a of 4. When your array of 2 is size 2 is full, then you will be assigning a new array and copy all the elements from second array to the new array. Then you have something called a of 8, then a of 60. Like this, you keep on increasing the size of the array. So increasing or resize is an operation in which you assign for it's two steps. First, uh, take a new array of bigger size, then copy old array into new array. Okay, so this is how it works actually. So dynamic array is not actually a dynamic. It's like they are using a resize function to achieve the same. Okay.
But Nishan, I think in resize as well, there is a input we can give that how much element or how much space we need. So resizing as well.
Come again.
There are other two functions like malloc and calloc. In that, it depends on the input, how much the person is giving the input, and on the basis of that, it will increase the memory, I guess. So
Again,
we
even
can,
if you are using a malloc or calloc only, internally they have to define a new array. They can't directly just increase the current memory address space to accommodate the new array. I'm pretty much sure about it.
fix, no, that is not fixed as we define like a of 10. So this is the fixed one. We can't change it. But when we using the malloc kind of thing, it depends
Okay.
on the
What
size of int.
happens? So what happens with the malloc at sometimes malloc is dynamic memory assignment. Okay. So whenever you use a malloc, at some point you have to define how much address space you need to use with the help of malloc.
Yes.
Okay. So what you are doing, you are giving a size to the array. Now let's
Uh,
suppose you use a malloc and you have given a size to the array, and that array got filled up. Then what happened? You have to resize it.
yes.
Okay. So that's the same thing.
Okay.
You have assigned some memory to the array, it's got filled up, then you have to resize it. You have to get the another array. So there is nothing called as dynamic array. Using malloc, you are doing the dynamic memory assignment, but it's a fixed array only. Okay.
Okay.
Somnath, Sridhar, Venkat, Shubham, Savita, Satya, any doubt so far?
Yeah, Nishant, I have a doubt. So exactly when the memory size gets doubled, while inserting the element in the last index or the index the before the last index, is there any conditions like that?
No. So first of all, itself not got doubled. It's like whenever you use an array and you find out that your array is full, you have to take a new array of double the size and copy the old element to the new element.
Okay.
Okay. Cool. So before going ahead, we have talked about the traversing operation. What is the complexity here? O of n. O of n, because we are accessing the n elements. So the total processing gets is order of n only, without using any extra space. Now, this is all about the array. We will be discussing more in the array by taking some of the problems. Guys, any doubt? Nikhil?
Can you elaborate the 3D arrays once again, as in how do you traverse and 3D arrays?
That we will look once we got into that problem.
Okay.
Generally, how you do is first you have to access the. I will tell you about the rows and columns also, and the pages also. Okay, how you access in the 2D array, how you access in the pages. Okay, but you first brief overview is first you have to access the page, and then page is having its own memory address. Okay, for example, this page is ABC1, this will be ABC2, this will be ABC3. So ABC1 plus, suppose second page you want to access and the second row. So the row calculation will be happen there. Okay, so I will let you know. Okay, so that we will go into much deep when we will using that particular. Will that help?
Yeah, cool.
Okay, so if you are good, we can start with a very simple problem, which I want to talk to you guys about.
Nishan, can you just tell us any real life implementation of array?
Okay, when we say real life implementation in terms of coding or in terms of any real time analogy, Shom, you are not audible. Guys, is it not audible to me only or to all of you?
No,
It is
it is not audible.
Hello?
Yeah, Shom, you are not audible. Yeah, so the real life, what happens is array, linked list, tree are the basic data structure. They helps to create the advanced data structure. For example, uh, dynamic programming. The core of the dynamic programming is memorization, which uses array to memorize the solution of the subproblems. So there is an usage of array. Second is priority queue. Priority queue is a data structure which helps you to get the maximum or minimum in order of one time. The implementation of that is based on the array only. Because of the direct addressing, it is very easy to heapify the elements within the heap. Okay, so that will be more clear when we will discuss in the priority queue. Another thing is in day-to-day life we use an array. We declare an means in the coding also we use the array. Let me tell you about. Yeah, in Java you do a array list. Okay, so in the array list the basic implementation comes to the array only. So the basic data structures helps to build the advanced data structures. For example, as I told you, the dynamic programming. When I was working in Myntra, I have used the dynamic programming to solve uh, some this what we call as discount types. Okay, for calculating the final price of the product. There I have used a 3D array. Not sorry, 3D array, 2D array, because 2D array is used to store the value of subproblems. Okay, like that, the real life, I have used the array. Hope I answer your question, Shubha.
Yeah, I'm audible now. Hello, I'm audible now.
Yes, Shubham, you are audible.
Yeah, Nishan, one more thing that what I'm asking, I forget the question now. You can
Sure.
carry on.
Whenever you guys, one thing is, whenever if I am speaking and you have a doubt, please put it in the chat so it will not be lost. Okay, you don't have to wait for me to ask you for the doubt. Okay, you at that time you can put it in the chat. I can go through all the doubts within the chat. Okay. So
Yeah.
okay. So what I want to do, I want to start with the problem section. So I want to
Um, yeah, Nishan, I am asking for the list. Means in Python we have a concept of list. So in that thing, there is no as such of a dynamic location or dynamic memory allocation. So can you
okay.
brief me on that thing?
Okay, I will do it, but I will do it after the class because that
Uh,
is specific to Python. Okay, it is not a relevant doubt for all the people here. Okay, I will
okay.
take it up.
Okay.
You can just note it in your notebook. Then we will discuss it. So, coming to the problem section, I want to start with the very basic. So, what happens with the arrays? Array is a very broad topic. Array contains a lot of things, lot of tips and tricks are there in there. A lot of type of the approaches are there. Okay, but I want to start with the very simple, which most of the people don't use or don't even bother to mention it. So let's start a very whenever we are solving problem, any problem we are solving, please try to understand the problem first. If you are having any assumptions or doubts regarding the problem, please clarify it with me. Then try to think about any approach. Okay, take your time. Whenever you have an approach in hand, don't code it. First, try to run your approach over the given input. Once your approach is working, okay, then think about any other input, okay, on which your approach should work. Then once that is done, think about how what will be the complexity there, how you can optimize. Okay, so this is a whole lot of thinking process which we have to practice for our means it could be a routine for us. For any problem in the data structure, this should be a routine. In the interview also, you have to follow the same thing. Don't be in a hurry to speak your approach out. Okay, don't be in a hurry. Means, and we understand that sometimes you can click an approach within a seconds. Don't be in a hurry, because when you communicate your approach, you have to be sure. Okay, it should be a working approach. Even if it is not the best approach, it should be a working approach. Then what happens is, when you communicate your approach, it should be in a simple language. Don't tell the code in your explanation. Means don't tell that, okay, there is a for loop which goes from I equals to 0 to n, and then it will do the printf like that. Don't do that. It will be very hard for the interviewer to follow. Always make it the simple statement that I will go through all the elements in the array and print all the elements. Simple. That's it. Now, yeah, so that is how we are going to follow. And also, the most important, whenever you have an approach, please use the chat to talk to me. Don't disrupt the thinking of other people, because everybody is start thinking when the problem is given. If you say something, they stop thinking in that direction and they start thinking something else. Don't do that. Let everybody think. If you have something to discuss with me, please use the chat box. Okay. Once everybody is done, then we will start writing all the approaches, all the working approaches over the blackboard and see what will be the best. We can follow this. Can we follow this? Manu, Nikhil, Raju, Savita,
Yeah.
Shivam.
Yeah.
Another thing is, whenever you have a doubt, please raise your hand. Okay, please raise your hand first. Because what happens is, two, three people can have the doubt at the same time, it will be very chaotic. When you raise the hand, I will go one by one to solve your doubt. Another thing is, when you understand anything, you can have a thumbs up. Okay, so that sometimes the mic will not work or work. Okay, so you can have a thumbs up emoji to tell me that, okay, everything is clear to you. Cool. Okay, can we start now? Somna, Sridhar, Venkat, Shiva.
Yeah.
Yes.
Okay. Okay. The very first problem which we are talking about is to place element. right hand side. What you have to do, you have to replace the element. So the problem statement is, this is the problem statement. Suppose we have been given an array. Okay, we have given an array. In array, we have to replace every element by the greater element on the right hand side. What happens in the array is, suppose the array is given like this, 16, 17, 4, 3, 5, and 2. For any index, there are two sides. This we called as right hand side. This we called as left hand side. This we call as right hand side. This we call as left hand side. So what the problem says that for every element, you have to replace the greater element on the right hand side. So whatever the elements you are left with on the right hand side, you have to find the maximum and you have to replace it by. It is also mentioned that while making the selection, you don't have to include the current element. I just write it down. So let's see how this input and output comes. How the output for this input comes. For 2, I know that there is no RHS, no right hand side. So I will be using -1 to tell that, okay, this is minus. For 5, the elements on the right hand side are 2. So the maximum element is 2 only. So 5 should be replaced by 2. For 3, the elements on the right hand side are 4, 5 and 2. So it should be replaced by maximum. For 4, the elements on the right hand side are 3, 5 and 2. So it should be replaced by 5. For 17, the elements on the right hand side are 4, 3, 5 and 2. So the maximum element is 5. It should be replaced by 5. For 16, the maximum element on the right hand side, the elements on the right hand side are 17, 4, 3, 5 and 2. So it should be replaced by 17. Okay. So again, all the elements on the right hand side, you have to find the greater element or the maximum element, and then you have to replace the current element by the maximum element. Okay. This is how we have to do. Is the problem statement clear? Do anyone is having any doubt? If you have any doubt, raise your hand. Yes, Ankit?
Size of the array would be can be one as well. The length of the array, or means it
Sorry.
the range of the length of the array will be greater than equal to 0.
It can be. And guys, again, please raise your hand first if you have any doubt. Okay. Because in the long run, it's become more and more chaotic. Okay. So the length of the array can be 0, can be 1, or can be 0 or more than.
In case of 0, what we need to return as a part of the problem statement?
Empty array. Okay. Try to understand the okay. Try to understand the problem. Ask me the doubts. Guys, again, one thing I want to clarify or state in the starting, some of you might feel that I am going slow, and I will be going slow for the first few classes because I want everybody to be on the same page. Few of you are very good with the DS. You have solved like a number of problems on Gate Code or something. Okay. But there are the certain people who are very new to the DS. They are getting comfortable with the DS. I have to take everybody with the same pace so that everybody will be comfortable. So the people who feel like they are, I'm going slow, please talk to me. Okay. And the first few classes, the pace will be very low. Cool. And guys, please let me know if you have any doubt or anything. Okay. So that I can help you out with. Because all the problems are anyhow connected to each other or their understandings are the same. Okay, the thought process is same. So please let me know whenever you have a doubt. Don't keep the doubt to yourself. Okay, if you don't speak it out, please let me know in the chat. I will help you there. But please let me know the doubts. And guys, don't code it without discussing the approach. Guys, are you trying? Manu, Nikhil, Satya, Savita, Shubham.
I'm working on.
Sorry.
I'm working on.
Take your time. We are not in a hurry. Take your time. Always try with a brute force approach. Okay. The way I have explained, give a hint on how you can do with the help of a brute force approach. Don't try to optimize in the first place. With the brute force approach, always try to look at what is the point in a brute force approach is making the complexity high. Then we will improve on that one. Okay.
Nishant. Hello guys, we need to return it or we need to print it out.
I think
Guys,
we need to change in same array.
okay. Now, Shubham, the thing is, this is the first question everybody should be asking before solving the problem. There is one word mentioned here that you have to replace. It means that you don't have to return it. You have to modify the same array. So the function signature should be look like this. One more thing is, while you are going to do the implementation, you don't have to look around for the main functions or the driver functions you have to return. You can directly write the function signature. Okay, so yeah, this is void. Let's name it replace right hand side, and you can have int there, and let's say size is also given to you. Yeah, for the simplicity, because this is the very first problem we are solving. So this is the function signature which is given to you, and this is where you have to put your code in. But again, I don't want you to write the code right away. First, we will be discussing the approach. Yes, Nikhil, what is your doubt?
No, just asking when we are discussing that. It's all good. We can discuss now. I thought we are discussing in the chat.
We will be discussing. See, if you have any thought, you can give me in the chat. I will reply there. But I want to give everybody enough time to think about it. Okay. So still some people still thinking. When I feel like that, uh, almost everybody is done with the thinking, then we start discussing it.
Yep. All right.
Okay. Here. Okay. So I want to discuss first about the brute force approach here. Brute force approach is an approach which is very the basic one, and you will try to hit every possible solution for it to see whether you get the answer or not. Sometimes you call it as a brute force approach, and sometimes you call it as the naive approach. Both the words are the same. Okay. Now, what happens here is, as I explained to you guys, that for every element, you have to look into the right hand side and see what is the maximum element you will get. Okay. So what you can do is, what will be the brute force approach in that case is, I can start from the first element. Okay, I can start from the first element, let it be I. Then I will go through all the other element with j, which will be traveling from I plus 1 to n minus 1, and see what is the maximum element. So for every current element, I will be trying to find the maximum element, and then I will be replacing it. For 16, I will be looking between 17 and 2. For 17, I will be looking between the 4 and 2. For 4, I will be looking between 3 and 2. And 5, I will be looking at 2 only. Okay. In this manner, so how we can say that for every element, I will be trying to find the maximum element in the remaining elements. So this approach can be done. Okay. So how I can write a simple pseudocode like this: int I equals to 0, I less than n, I plus plus. So for j equals to I plus 1, Okay, j less than n and j plus. What we will be doing, finding the maximum element. Okay, so whatever the maximum element you will get here, you will be replacing a of I with that element. Let's say in the temp you will be holding the, or let's say max you will be holding here. That is the case. That is the brute force of the neighbor. Now one thing is, everybody listen to me very carefully. I got the approach from many people. Okay, they know the approach, but they don't know what is the thought process behind it, how they come to know that approach, and that is the most important part. Here, I am not going to explain the second approach right away. I want to give you a food to thought. Here, do you think every time we are finding the maximum? Okay, that is not something very good. What we can do, we try to use the already known information with us. Okay. If we know some already known information with us, we can use that to avoid recalculating the maximum every time. So here, what else are we doing? What is the value? So think how you can reuse the values. Okay, in that direction means how you can reuse the previously calculated answer to get. So try to think in that direction. What this 2 means, what is this 5, and how they are mattered to this value 3. How this 2 and 5 are matter to 3. How they can be useful for 3. Okay, think in that direction. Take 5 minutes, 10 minutes of your time, and then we will start discussing the better approach or the second approach. Okay, so this is the hint. Okay. Okay, let's try to see what this hint going to tell us about. Okay, before going there, is brute force approach clear to everyone? Do anyone is having any doubt in the brute force approach? Savita, Satya, Nikhil, Somnath, Sridhar.
Yes.
Now, let's see what this hints mean. If you look closely here at 5 and 2, what is 2 relative to 5? 2 is the maximum element, among all elements which are right on the, which are on right side of 5. Okay, which are on the right side of 5. Maximum element among all the elements which are on the right side of 5. Okay, like this. Okay. Now, if we look at 3, how they are making sense for 5, how they are making sense to 3. So if we look closely at 3, this 2 is the maximum element among all the elements after the next element. So 5 is the next element for 3. So for 3, how they are making sense? 2 is maximum of all elements after next element. Okay, after next element. The thing is, to get the maximum for 3, we need this much. But 2, we already know as maximum after 5. It is just that 5 and 2 are not compared. Okay. If we compare 5 and 2, we will get the maximum for 3 among all the elements in the right hand side. Okay. So this is what. So how they are relevant to 3? Again, I am saying 2 is maximum among all the elements after the 5. 5 is the next element. So it is not just compared the 5, or in their comparison, the 5 is not considered. So what we have to do, we have to just compare 5 and 2, because 2 is already the maximum element. If we compare it 5, mean the comparison is among the 5 also. Okay. So we compare 5 and 2, and that becomes the greatest element for the 5. Okay. So if I have to generalize this, it means that for I, the maximum element for I is the maximum of A of I plus 1 and maximum till I plus 1. Okay. This maximum is nothing but maximum of all, among all the elements between I plus 2 till A of n minus 2. Okay. So this is how we are reusing the already calculated maximum to get the current maximum. Okay. So this is the main motivation behind reusing the already calculated information to get the current information. Okay. So that's how we can calculate the maximum element for I. Okay. So this is the far better approach as compared to the brute force approach. In the brute force approach, the complexity which we are observing was order of n square. Okay, why order of n square? Because for every element in the outside loop, we are processing almost every element in the inside. That's why the complexity is order of n square. And the better approach. First, let's try to write the code for better approach. First, before going to the code, try to understand the approach first. Whether this approach is how this approaches. Okay, first try to understand this. Is this clear to you or not? So how we can iterate through, how we can get the output for all the elements? Let's see. 16, 17, 4, 3, 5, 2. For 2, I already know that there is no element on the right hand side, so this is minus 2. Now for 5, I just need to compare 5 and 2, which is maximum 2. For 3, I need to compare 5 and 2, which is maximum 5. For 4, I need to compare 5 and 3, which is maximum 5. For 17, I need to compare 5 and 4, which is maximum 5. For 17, I need to compare, for 16, I need to compare 17 and 5, which is maximum 70. Okay, so that is how I got the answer as the output. Good. Try to do it by yourself for the second input for this one. Okay, for this one, try to do that. And see whether you are having any doubt or something. If you have any doubt, please raise your hand. Is anyone having any doubt here? Shedar, Soma, Shubham? Or are we good? So far, are we good?
Yes, sir.
Shedar, Shubham, Satya, Savita, Nikhil, Manu. Now let's see how we can implement this. Okay. So one way to implement this approach is to take an extra array. What we can do? We can take an extra array. Okay. And guys, the important part I want to talk about is the motivation. Again, I'm saying, because I got this approach from many people that we can do this, but why we are doing this? That's the most important question. Because same thing happened in the interview also. I also take interviews. And when I got the answers, direct answers, then my next question is how you come to this approach, how you think of this approach, and how this is making a difference here. Okay, all these questions comes. So one way to implement this is I can take an extra array. Okay, I will initialize it with -1. Then I will be comparing the original array and the extra array. So let's say this is the temper. So I will be just comparing the temp of I to fill temp of I will be just comparing that what will be the maximum of A of I plus 1 and temp of I plus 1. Okay. This is simply I am using to fill. So 2 and 1 it will be 2, 5 and 2 it will be 5, 3 and 5 it will be 5, 4 and 5 it will be 5, 17 and 5 it will be 7. Okay. Now what happens is this approach will work. This is definitely work. The complexity of this approach is order of n only. Okay. Why? Because we need to process all the elements only single time. So the total processing will be n only. That's why its complexity is order of n. Another thing is Another thing is that extra space we are taking is n, because we have taken extra array to get the answer. Okay, when you take the extra array, you need to put it back with the original array. That we have to assign original array to A, because we want to update the original array only. Because if you go and see, I am not replacing or returning any array here. Sorry, not replacing. I am not returning any array here. Okay, so you need to put it back in the original array. Another thing is, we can avoid using this array completely. Okay. Now what I can do, I can completely avoid using this array. How I can do this? What is important to us? What, coming back here, what is important to us? The element which is got replaced. The element which is got replaced means this element which is got replaced. If I keep this element into a temporary variable in every iteration, I will just simply use them without using any extra array. So how we are getting the answer? We are just comparing this two. For this, we are comparing this two. When we compare this two and replace this two, I just need to keep this in another variable or some temporary variable to be used in the next iteration. Okay, so I can completely avoid using an array by using a simple variable. Okay, so this way we can avoid using a whole array to achieve the same thing. Okay, any doubt here?
Sir, I didn't get it. Can you sir repeat again?
Sure. Which part? The second more
Yes,
optic.
without extra space.
Okay. So what, to understand that, you need to understand that you need to understand what you need to get the answer. Okay, how you are getting the answer that you need. So for example, for 2 it is -1, for 5 it will be comparing this and this, it will be 2, for 3 comparing this and this. What happens is, if you are not using extra array, what you have done, you have replaced 5 with this 2. Your 5 will be lost. Okay, if you are not using extra array, your 5 will be replaced by 2, and your 5, sorry for that, excuse me. So your 5 will be replaced and 5 will be lost. So now for 3, I need to compare 5 and 2, but 5 will be lost. So to avoiding 5 to get lost, I will be keeping 5 into 10 before it get replaced. Okay, now you will replace 5 with the 2. So for 3, you need to just compare temporary variable and 5, temporary variable and 2. So that will be 5. Again, before replacing 3 with 5, you need to update the temporary variable to hold 3. Okay, so that it can be used for the next iteration. Okay, so in this way, we can use a temporary variable to hold the current array value before it got replaced. Okay,
Okay, sir, now got it.
anyone is having any doubt, please try to follow the same by yourself on the second input and try to write the code for the same. This one. Okay, this one is a problem. I will put it in the chat as well. Guys are trying to solve the same. Anu, Aman, Nikhil, Satya.
Yes.
Okay. So, guys, is the thought process clear to all of you that how we are solving this problem and what is the main reason of using or how we are using the reusing the already calculated maximum variable? Savita, Satya, Shubham.
Yeah.
Yes.
Okay, try to write the code for this and then I will help you. Yes, Shubham.
Yeah, Nishant. When I'm solving this question, I uses the same technique that is inside loop, means two nested loop. But when you tell that that is from the last start with the last one, means how we develop this kind of thing. Means on a normal go, we thought that yeah, it is a simple array and starting from the starting index. But if
So,
in this question we need to get from the backward direction, mean backward to forward, it will get easier.
so the
So
thing is, again, it comes with the practice. The thought process build ups with a lot of practice. So what happens is, yeah, your question is completely valid. That how you come to know that and how we approach this plays a big role here. Because from the
yeah,
brute force, I already know that I need to calculate the maximum every time. But what if I have already used previously calculated value? Okay, what happens is when we solving more and more problems, you will have 3, 4 directions to look for. For example, whenever the array problems comes in, you will start looking that, okay, can I use a previously used value or can I use 2 pointers? Can sliding window will be helpful here or can sorting be helpful here like that? Okay. So when you solve more and more problems, it will going to help you out with it.
okay, yeah.
Oh, cool. So yeah, Ankit, tell me.
Yeah, actually, Nishant, I just understand this approach. The problem is that while swapping the numbers, like when we say that okay, we are comparing two, let's say 5 and 2, right? From the last, when we are comparing the 5 and 2 for the position 3, correct? So then, basically to swap the numbers, I am using the third variable as well. Like I'm using
But
the three
why you have
variable.
to swap the variable? There's no need to swap the variable. Now we are just comparing whichever is the greater. That will be our answer.
But
Okay.
we need to store that value, right, in the
So
temp
do one
variable.
thing. I'm going to solve this here. Just follow me and see where you have done or where is the
Yeah,
gap in
yeah,
the image.
sure. Okay, thanks.
So int n is equals to a dot length. I'm taking the length of the array. Then I am taking the temporary variable. Let's say temp equals to. I will be storing the last element into this. And in the last element, I am going to replace it with -1 because there is no element after the last element. Then for int I equals to n minus 2, I will be going through and I should be greater than equals to 0, I minus minus. Then int I will be taking the current element into this variable a of I. Then I will be replacing, then I will be checking who is the greater among the a of I plus 1 and 10. So 10. If a of I plus 1 is greater than 10, then a of I will be equals to a of I plus 1. Else a of I will be equals to 10. Okay. Now I have to update my temp because temp should hold the current, I mean, previously replaced value. So I will be assigning like this. Okay. So what this will help us out, and I will be returning here the original array. Like this. I will be checking if n is equals to 0, return simply. Okay, this is the, let's see whether this is working or not. Yeah, this is working for the current input. Let's see whether it is working for all the test cases. Yeah, it is working for all the other test cases as well. Cool. So Ankit, there is no need of swapping or anything.
Maybe I have done something wrong. I'm
Okay,
actually
just
so basically when you are comparing a of array I plus 1 greater than m, then you are initializing to a of array I directly, right?
oh, do one thing. Again, go through the recording once and see where the gap comes. Okay.
Yeah, sure. Yeah.
Cool. Yeah. So this is how we solve this problem. Now I want to modify this problem. Are we good with this problem? Lakshya, Manu, Nikhil, Raju, Satya, Savita, Somnath,
Yes.
Venkat. Okay. So the one modification I want to do is the problem statement remains same. Means you have to replace the current element by the uh, data element on the right hand side. But the issue comes is you have to include the current element also in your calculation. Okay. Previously we are not including the current element. Now you have to include the current element. I will just put okay, try to understand the problem and see what difference it is going to make in the previous approach. And guys, the link to this notebook is already in the WhatsApp description. So if you have to refer to any class assignment or anything, you can directly go and open the notebook and you can see all the notes which we are writing here. Okay. It's already in the WhatsApp group description. So what is the difference here in the previous and here? What we have to do, the comparison difference is only the thing which differ these two. So 2 already we know that it is going to be, so it is not -1 now because you have to include the current element also. So for 2 the maximum element is 2. For 5 we know that till 2 the maximum element is 2. So 5 and 2 we need to compare, that is 5. Now we are doing comparison like this. 5 and 3 bigger is 5. 5 and 4 bigger is 5. 5 and 17 bigger is 17. 17 and 16 bigger is 17. Okay, so the comparison is like that. But the only difference is now instead of comparing with the next two values, we will be comparing with the current value and the previous max because that is the maximum so far. Okay. Any doubt here? Anyone?
No.
Okay. So this you have to code it. This is a class assignment, and another problem I want to give for the class assignment is like the way we have calculated for the right hand side, you have to do it for the left hand side. Okay, this is also you have to write the code. The way we have done it for the right hand side, the same way you have to do it for the left hand side. Okay, so before coming to the class tomorrow, you have to complete this two things. So replace getter element, replace every element with getter element of every replace elements on left hand side. Can you guys complete this part?
Sure.
You have to write the code as well for this problem and this problem. Savita, Shubham, Somnath, Venkat, Lakshya. Okay.
Okay, Nishan.
Yes.
Cool. So today I'm stopping here. Okay, tomorrow we will be meeting at the same time and we will be discussing more problem around the array. And tomorrow only I will be posting the array part 1 assignment part 1. Okay.
Okay, Nishan.
Thank you guys. Yeah,
Thank you, Nishan.
Nishan, where do I find the notes? I don't
It's
see it
in. Are you added to the WhatsApp group?
Yes, yesterday. Yeah.
In the WhatsApp group description. So every group have a description. No? So there I have put it the link.
Oh, okay. All right. Thanks.
Okay. Thank you guys.
Nishan, that list concept you asked me to bring up.
So I have a hard stop right now. Tomorrow after the class we will discuss. Okay, or I will
Okay.
offline message you.
Okay.
Thank you.